Fine. So guys, myself Ankit Sharma, I welcome once again to all of you in BYJU'S Exam Prep. So today we are going to have a very important session regarding BARC. Basically this will be regarding the questions of irrigation. So without wasting much of our time, let us start the session. Abhishek ji, good afternoon everyone. So guys, please do share the session with your friends in all the Telegram groups, all the WhatsApp groups you have. So that the maximum of people can join and they can take the benefit of this session. So shall we start the session? Everyone please give me thumbs up sign. And just for your information guys, basically today at 8 p.m. I'll be again coming live at the same place, right? Your very own BYJU'S Exam Prep GATE channel. Yes, Abhishek ji, that is out, right? I'll be taking sure one video on it very soon. Now the point is this, basically today at 8 p.m. we'll be discussing the questions of leveling, the questions of compass today at 8 p.m. so please do join me today at 8 p.m. at your very own BYJU'S Exam Prep GATE channel. So guys, let's start the session without wasting your time. So guys, this is myself, I'm Ankit Sharma, an ex-IAS officer having teaching experience more than 12 years in the field of GATE and ESE, right? So guys, this is our first question. Can you please help me out with this question, the solution of this question? The question is, time required to irrigate a strip of area 0.203 hectare by a stream discharge of 0.043 cubic to provide an average depth of 6.35 centimeter to the field, is assumed to average rate of infiltration to be 5 centimeter per hour. So guys, this is the question. How to solve this question? I do believe that everybody is aware about the formula. That is T is equal to 2.303, right? Y by F log to the base 10 Q upon Q minus AF, right? This is the formula. Everybody is aware about this formula. Now let us put the values in this formula. So T is equal to 2.303 into Y. Y is the average depth of flow, and how much is the average depth of flow? 6.35 centimeter. So 6.35 centimeter divided by average infiltration rate, that is 5 centimeter per hour. So guys, over here I am putting the infiltration as 5 centimeter per hour. Now yes Abhishek ji, yes Star Mudasir ji, very good, 1.35. Now guys, please try to understand that Y, the unit of Y is in terms of centimeter, and the unit of F given in the question is in terms of centimeter per hour. So basically in numerator, I will write it over here. In numerator the unit is centimeter, and this in denominator unit is centimeter per hour. So basically what will be happening, this centimeter will get cancelled and this hour will come at the top, right? This will come at the top. So whatever is the unit of my infiltration rate, so the denominator of that infiltration rate will be affecting the unit of answer, right? Into log to the base 10 Q upon Q is how much? That is 0.043 cubic. So 0.043. So I'm keeping the value of this cubic in terms of m cube per second. The discharge in terms of m cube per second. Since numerator is in m cube per second, denominator should also be in m cube per second. So again discharge 0.043. Now area as given in the question is in terms of hectare, so I need to convert this area in terms of meter square. So it will be how much? 0.203. Sorry, I have to convert it, right? So it will be 2030, right? This much meter square. Now F. Now over here F is basically 5 centimeter per hour. I need to convert this in terms of meter per second. So into 5 into 10 to power of minus 2 divided by 3600. 3600, right? So if we solve this, can we get the answer? T is equal to 1.35 hours. So our answer will be option B, everyone. So Mundasir ji and Abhishek ji were absolutely right. Agreed, guys? Is this clear? Shall we move to the next question? Shall we move to the next question? Are you ready for it? Fine. Let's move to the next question. Irrigation water having the concentration of sodium ion, calcium ion and magnesium ion as 23 and 1 milli equivalents per liter respectively will be classified as low sodium water, medium sodium water, high sodium water, very high sodium water. So guys, as far as I do believe that you guys know the range, right, of SAR. SAR value for low sodium water is 0 to 10. For medium sodium water is 10 to 18. For high sodium water it is 18 to 26. And this one is greater than 26. Right? This is the range. Okay, good, Abhishek LPG, good. Now SAR value, and this is called as S1, S2, S3, S4, right? So SAR value is concentration of sodium ion divided by under root of concentration of calcium ion plus concentration of magnesium ion divide by 2. So this value will be equal to 20 plus under root of 3 plus 1 divided by 2. Right? So it will be 10 root 2. And root 2 value we know that 1.414. Good afternoon, Akash ji. Good afternoon. Akash ji, I believe that in the previous homework question which I have given, you have only answered one question, right? So you are supposed to answer the other questions also. So what is the answer? Answer is Bombay medium sodium water, right? Abhishek ji was right, absolutely right. Right. And you can also visit my Telegram channel, guys, Civil by Ankit Sir. Over there, basically whatever homework questions I give, basically I post solutions over there. Right. So next question. A sandy loam soil has water holding capacity of 140 mm per meter between field capacity and wilting point. Area to be irrigated is 60 hectare and depth of effective root zone is 0.3 meter. The management allowed soil moisture depletion as 40% and consumptive use is 5 mm per day. Conveyance and application efficiency are obtained to be 80% and 50% respectively. There are no leaching requirement as well as no rainfall and groundwater contribution to the crop water requirement. The frequency of irrigation in days and the field irrigation requirement in MQ will be. So guys, can we solve this question? Can we solve this question? Yes or no? So we need to determine frequency of irrigation, right? FW, that is D dash by CU per day, and Cu per day is nothing but 5 mm per day, right? That is 5 mm per day. So we are supposed to determine D dash. Now over here from the question we can see that basically if the root zone depth is 1 meter, then the amount of water holding capacity is 140 mm per meter, right? But in reality the root zone depth is 0.3 meter. So how much will be the water holding capacity? 140 into 0.3. Agreed? 140 into 0.3. Clear everyone? Now out of this available water, how much water is allowed to be consumed? Right? Management allowed soil moisture depletion as 40%. So 40% of it is allowed to be consumed. So this value is allowed to be consumed. So how much is the value of D dash? Can you please let me know with the value of D dash? Is it coming as 16.8 mm? Right? 16.8 mm. So FW will be equal to 16.8 divided by 5, that is equal to 3 point. How much? 3 point. How much? 0, 3, something like this. How much is the value coming? 3.36. Yes, 3.36. Right? But we always do the round down, so it is equal to 3 days. 3 days. So these two cannot be the answers. These two cannot be the answers, right? Now further, after that, what we need to determine? We need to determine that is field irrigation requirement. So we know that FIR is equal to NIR divided by application efficiency. Further, NIR is equal to CIR plus leaching requirement plus pre-sowing requirement. Now this will be 0, this will be 0, as about both of them nothing is mentioned in the question. About both of them nothing is mentioned in the question. Now NIR will be equal to CIR. Okay, you guys have started giving the answer C. Okay, fine, let's check. Let's check. Right? So CIR. So what is the total water to be consumed? Can I say that we are giving the water after 3 days and per day used water is? So volume of water consumed will be nothing but my CIR. We are giving the water to the soil after every 3 days, and every day how much the water is being consumed? Can I tell that every day the amount of water which is being consumed, that is 5 mm per day? So 3 into 5 into 10 to power of minus 3, this will be the net depth of water which is consumed. And this depth of water is to be supplied in which area? How much is the area? How much is the area in which water is to be supplied? 60 hectare, right? 60 hectare. So into 60 into 10 to power of 4. Right? So if we solve this, what value we will receive? What value we will receive? Can I please have the value? Will it be this 39? Right? First let us take over for the 0. Right? This will be 10 to power of 5, 10 to power of 2 will remain. Right? And this one is basically how much? 6, 5, 30, 30, 90. 9 into 10 to power of 3 m cube. Right? But we need to determine FIR. So FIR will be 9 into 10 to the power of 3 divided by 0.5. That is application efficiency. So 18 into 10 to the power of 3 m cube. Right? Answer will be A. Is that clear? So Akash ji, Star, Mudasir ji were giving the answer as C. Will that be the answer? Answer will be A. Why you got the answer C? Abhishek LPG 1080 or 1800? 9 divided by 0.5. So it will be twice of it, right? Abhishek ji. Why we can't take conveyance efficiency? C. Good afternoon, Masoor ji. Good afternoon. C. At first we have what value? CIR. Summation of consumptive requirement minus summation of R effective. Right? Thereafter we have NIR is equal to CIR plus pre-sowing requirement plus leaching requirement. Abhishek ji, is your doubt solved? Then we have FIR is equal to NIR by eta A, and then we have gross irrigation requirement, that is equal to FIR by eta C. Is this clear? Akash ji. Sure Abhishek ji, no issues. So that's the reason. Clear? Let's move to the next question. This is the next question. In a cultivated area, soil has porosity of 45% and field capacity of 38%. For a particular crop, the root zone depth is 1 meter. The permanent wilting point is 10% and consumptive use is 15 mm per day. If irrigation efficiency is 16%, what should be the frequency of irrigation such that moisture content does not fall below 50% of available moisture? Can I please have the solution of this? Can I please have the solution of this? Let me grab the calculator for you guys. Meanwhile, you please solve this. So guys, I have got my calculator. Cool. So, porosity, right? What should be the frequency of irrigation? So again guys, we are aware about the fact that FW is equal to D dash by CU per day. And how much is CU per day? That is 15 mm per day. That is 15 mm per day. Now D dash, we know that gamma D by gamma W into capital D into FC minus M naught, right? But we also know that gamma D by gamma W is equal to N by FC, provided that the degree of saturation is 100%. Provided that the degree of saturation is 100%. Right? Further, can I write this? FC minus M naught will be equal to 0.5 times of FC minus phi. right? Can we write that? Because moisture content does not fall below 50% of maximum available moisture. So the available moisture is Fc minus phi, and we are supposed to consume 50% of it only. We are supposed to consume 50% of it only. Agreed, everyone? Clear? So now D dash would be equal to, how much is porosity? 0.45. And how much is field capacity? 0.38. How much is the root zone depth? 1 meter. So let me put it 1000 over here so that I'll get the value of D dash in terms of mm, into 0.5 of Fc 38. 0.38 minus phi is 10%, right? 0.1. So how much is the value? How much is the value? Can we please have the value? 0.45 divided by 0.38 into 1000 into 0.5 into 0.38 minus 0.1. This would be 165.789 mm, right? And Fw will be equal to 165.789 divided by how much is consumption? 15 mm. So divided by 15 will be equal to, that will be equal to 11.05. So frequency of irrigation will be how much? 11 days. It will be 11 days. Answer will be D. Very good everyone. Very good everyone. Now please do let me know one thing. Over here in the question, this irrigation efficiency is also mentioned as 60%. Do we need to use it? Irrigation efficiency is also given as 60%. Do we need to use it? Do we need to use this? Yes or no? Do we need to use this efficiency? Yes, Abhishek LPG, when we need to calculate the water to be supplied, then we only require to use this irrigation efficiency. Otherwise, we don't need to use this. Yes. The volume of water to be supplied, right? Then only we have to use this. Otherwise, we don't have to use this. Good. Next. This is the question. Calculate the bed width of an irrigation channel to carry a discharge of 6 cubic and the side slope of the channel are critical velocity ratio 0.9, depth of flow. Right? Side slope of the channel may be taken as half horizontal, 1 vertical. Half horizontal, 1 vertical. Right? This should be the side slope. Right? So can I have the answer please? This is the question of Lacey or this is the question of Kennedy? This is the question of Lacey or this is the question of Kennedy? Yes, Abhishek ji, it is for sure the question of Kennedy. Now basically we know that as per the Kennedy's, right, theory, V is equal to 0.55 m y to the power of 0.64. So V is equal to 0.55. M is how much? 0.9. That is critical velocity ratio into y. Depth of flow is 0.8. 0.8 to the power of 0.64. So this value is how much? 0.43 meter per second. Right? Further, discharge is given. So can I write A is equal to Q by V? And if we do A is equal to Q by V, how much value will be getting? 13.98 meter square. Right? 13.98 meter square. Now, further, A is equal to B plus XY into Y. Right? So, 13.98 is equal to B we need to determine plus 0.5, Y 0.8 into 0.8. So, how much will be the B? How much will be the B? The value of B will come as 17.07 meter, isn't it? Answer would be C. Do you agree with this solution? Everyone, do you agree with the solution? Please let me know in the comment box. Shall we move to the next question? Abhishek ji is telling 15.84 coming. Right? No, 13.98 divided by 0.8 minus 0.4. No, Abhishek ji, I'm getting the value of 17.07. Please check. Might have done some mistake. Next. This is a question. In a wide alluvial river, the normal scour depth by Lacey's equation is 7.4 meter. For a discharge intensity of 10 m³ per second per meter width, normal scour depth is that river for a discharge. In that river for a discharge intensity of 30 m³ per second per meter is. So guys, please let me know the answer. What could be the possible answer? First of all, do you know the formula? Do you know the formula? Everyone, can I tell that over here R dash 1.35 small q square by f to the power of 1 by 3. Is this the formula for scouring depth? Okay, let's check. Abhishek ji, can we conclude that scouring depth is directly proportional to q to the power of 2 by 3? Right? It is directly proportional to q to the power of 2 by 3. So can we write R1 dash upon R2 dash, both are the scouring depth, their ratio, Q1 divided by Q2 whole to the power of 2 by 3. Can we write this? Simplest approach. No need to do other calculation. Yes, Abhishek ji. Absolutely, brother. Best of luck. Now R1. Let us say R1 is the value we need to determine. right? And R2 is the value, that is 7.4. Now similarly Q1 will be how much? 30, and Q2 will be how much? 10 to the power of 2 by 3. So if we solve this, R1 dash will be equal to 10.67 meter, isn't it? So the answer will be option A. Answer will be option A. Is that clear? Right, this is the best approach. See, instead of going for determining the value of F and all, we don't require the value of basically F over here, silt factor. Akash ji, it will be not 15, it will be 10.67, I guess. Please check. 30 to the power of 2 divided by 3. That is 9.65 into 7.4. Right? Clear? Is it coming 15 by calculation? Okay, fine. Then let's make it 15. I did not do the calculation, I just trusted on you guys, so it will be 15, right? So let's move to the another question. Sure, definitely. So it will be 15. Next question. This is the question, guys. This question is for your homework. We have more questions also. So answer I will give in comment box. And the solution will be given in my Telegram channel. Solution will be given by me in my Telegram channel. Clear everyone? And everyone, don't forget to join me tonight at 8 p.m. Right? I'll be having class of basically very important lecture we'll be discussing the questions of compass surveying. Over there I'll be discussing the question of the bearing of the sun, declination. Clear? So this is your question for homework. Further, please answer this one. The minimum size of the gravel that will not move in the bed of the wide rectangular channel of depth 0.6, 0.8 meter and longitudinal slope 0.0041. Very easy, right? It's very easy. The only formula we have to use over here, D is equal to 11RS. D is equal to 11RS. Right? Now, this is the size of the particle, average size of the particle. This is the hydraulic radius. This is the bed slope. Now, it is a wide rectangular channel. So in case of wide rectangular channel, in wide rectangular channel, what do we have? We have R is equal to Y. Do you know this relation? How this relation will come? Okay, let's check. Right? So D is equal to 11 into 0.8 into 0.0041. So how much this value is coming? It is coming 0.036 meter, right? So answer will be 36 mm. Answer will be 36 mm. Everyone, please don't forget to like the session. Everyone, please don't forget to like the session. Everyone. Clear? Shall we move to the next question? Yes, let's do that. Now, this is the question. At a horizontal joint of width 70 meter in a gravity dam, factor of safety against sliding is 1.05. If the sum of horizontal forces above the joint is 40 meganewton and the average shear strength of the joint is 1.4 megapascal, the shear friction factor at the joint is. So it's a very easy question, guys, right? We know that shear friction factor is equal to BQ plus mu summation V divided by summation H, right? Further, we know that factor of safety is equal to mu summation V divided by summation H. In the question, factor of safety against sliding is given as 1.05. So can we tell that mu summation V is equal to 1.05 into right, summation H, and how much is summation H? Horizontal forces 40. So this is the value. So shear friction factor will be equal to 1.05 into 40 plus BQ, right? B is 70 meter and Q is 1.4 megapascal. So it will be 70 into 1.4, right, divided by summation H, and that is my 40 meganewton. So how much is the value coming? Can I please have the answer? Okay, 3.5. Abhishek ji is giving the answer as D, 3.5. Yes, obviously the answer is, let me check, I have already solved this. Yes, 3.5. So answer will be Delhi 3.5. Clear, everyone? Any doubt with this? Let's move to the next question, everyone. Consider the following data regarding theoretical profile of dam. Permissible value of compressible stress sigma 350 tons per meter square, specific gravity of concrete S 2.4, uplift coefficient C 0.6 meter, the value of gamma 1 ton per m cube. The height and base width will be nearly. The height and base width will be nearly. So how to solve this? Do you remember the formula? Sigma 1 is equal to gamma WH GC minus C plus 1, right? So sigma 1 is 350 tons per meter square. Gamma W will be how much? 1000 kg per m cube, and 1000 kg is 1 ton. So 1, right? The value of this gamma W will be 1, simply 1 into H GC, that is 2.4, uplift coefficient 0.6 plus 1. So the value of H is coming. How much is the value of H coming? 125, right? Is it coming 125.93? 350 divided by 2.8, 125 exactly is coming. Why you went wrong? There is no decimal. Yes, 125. Further, B is equal to H upon under root GC minus C. This is for the bed width. So B is equal to 125 upon under root 2.4 minus 1. Sorry, minus not 1, 0.6. Right, that will be equal to how much? 93 meters. So our answer will be option C. Answer will be option C. Guys, don't forget to hit the like button. Guys, please don't forget to hit the like button. Clear? This is the next question, guys. This is the next question and the last question of today. Can I please have the answer in the comment box? Uplift pressure at point E and D of a straight horizontal floor of negligible thickness with a sheet pile at downstream end are 28% and 20%. Okay, fine. Respectively, if the sheet pile is at upstream end of the floor, figure B, right? Figure A and figure B. Find the uplift pressure at D1 and C1. So guys, basically what do we have to do? We have to determine the uplift pressure at this place. At these places, the uplift pressure, right, over here, at point D it is 20%, at point E it is 28%. So how much will be the value at this and how much will be the value at this? Okay, Abhishek ji is the first one. 80 and 72. D1 and C1. At 80 it will be yes. At D1 it will be 80 and at C1 it will be 72. Why? Why guys? Without doing any calculation I have given the answer. See, the logic is very simple. As you can observe over here, the depth of upstream sheet pile and the downstream sheet pile both are equal. The depth of upstream sheet pile and the downstream sheet pile both are equal. So in such a case, basically what is the case when this depth is equal? Phi D plus phi D1 will be equal to 100%. Further, phi E plus phi C1 will also be 100%. This is the rule we have to use. Yes, yes Abhishek ji. So guys, this will be our answer, Bombay, right? Right? So that's all from my side, everyone. Thanks a lot to all of you. So guys, if there is any issue or any problem you guys are facing, you guys can let me know in the comment box, or what you can do, basically you can join my Telegram group Civil by Ankit Sir, and you can also connect with me there, and definitely I would love to give you the solution of the problem whatever you are facing. Clear everyone? So that's all from my side. Thanks a lot to all of you. And don't forget to join me at 8 PM session guys, live. Thank you everyone. Jai Hind.